Hello everyone, I'm Meghamala, working assistant professor from Institute of Aeronautical Engineering, and my subject is wireless communication and networks. And today I'm going to discuss about an important topic called cell sector topics. So in the previous classes we had discussed about the cell division. Okay, so we have discussed like cell splitting. In other way, we can call the cell division as cell splitting. So the cell splitting, cell sectoring, these are the very prominent techniques in order to reduce the interference. So in order to reduce the co-channel interferences, or else in order to reduce the disturbances when the user is taking up a call or when the user is making an initiation in order to have a communication. So these are the few techniques that there is a necessity to discuss. So the last class we have discussed about the cell splitting. So we know that word splitting. Splitting is nothing but dividing the cell. So we know that the basic communication has will take place in this wireless communication network using a base station. And we have a base station is a very prominent task, like, or else through the base station, with the help of base station, the communications will be happen. And also we have one more important thing is mobile stations. So we do have base stations and we do have mobile stations. So when the user wants to switch a call from the mobile station with the help of the base station, then he should not experience any sort of interferences. So usually the interferences will cause because of many reasons. So we can say that one of the reason, the two major reasons we can I can say is natural phenomenon and also the man-made structures. So these are the basic interferences where a signal can get disrupted. Okay, so for example, if I consider this natural phenomenon, I can say that because of bad weather conditions and also because of the day and night streaming, because of the solar flares, we do experience some interferences, or the signal strength of a particular the wave, when the wave is propagating through the atmospheric structure, then what happens is the signal strength get reduced. So because of all the interferences which are causing naturally and also through the man-made. So in order to overcome such sort of interferences, we do have some techniques in the wireless networks, that is cell splitting and cell sectoring. And as we have discussed, like natural phenomenon like solar flares and due to bad weather conditions, we do have also a man-made errors. So man-made errors are nothing but the tall buildings and tall trees. Because of this also, the signal will take a multi-path direction. So in order to, as the signal used to go in a straight direction, it has to, the signal has to experience the line of sight distance. But whereas due to the interferences of all these man-made structures and also the natural phenomenon, instead of taking a proper direction, the wave, it takes a multi-path direction in order to reach the receiver. So this is a multi-path direction. So when the wave is propagating through different directions, all multi-path distances, all multi-path directions, what happens is the signal fading can occur. So signal fading is nothing but the reduction in the signal strength is nothing but the signal fading. So these are all the factors where these are all the factors are pertaining to the reduction in the signal strength. So in order to overcome all these factors, what are we doing is, in the wireless and communication systems, we are going for this cell splitting as one of the important technique, and also the other technique is cell sectoring. So in the cell splitting, we had discussed that we know for example, this is a channel. So this channel consists of four different sort of cells. So cell 1, cell 2, cell 3, cell 4, and cell 5 and cell 6. So here we have 6 cells and we have one channel. So what happens is, when you here we are reducing the channel, or else we are splitting the channel. So one channel can be split into 3, or else one channel can be split into 2. So when the channel is getting splitted, what happens is the user can easily he can, or he or she, the user, whoever want to establish a channel, or else whoever want to establish a call, then that particular user he feels so comfortable. He feels so comfortable without any interference, or else without any disturbances. So here, by using these techniques, this user can easily establish a call. So the last class we have discussed about the cell splitting, and today we discuss about the cell sectoring. So this is also another method to increase the cell capacity and coverage by keeping cell radius unchanged and decreases the D by R ratio. So here, this is we say that in order to increase the capacity, or else in order to increase the cell coverage, we are going for the cell sectoring technique. So this is one of the prominent method, where here in this cell sectoring we do keep the radius of the radius is unchanged. The radius can be unchanged, and the ratio, that is D by R ratio, deviance by R ratio, can be decreased. So this is one the very first important point. And in this approach, the capacity improvement is achieved by reducing the number of cells in a cluster, and thus increasing the frequency reuse. So we know the frequency reuse concept. So the same frequency can be used in different channels. That means what? The different channels can use the same frequency, but here the important point is when the frequency is reused, or else when the frequency is used multiple times. Remember that the distance between the reused frequency must be far. So the isolation should be seen when the frequency is reused in different cells. The distance should be far from one cell to another cell. The neighboring cells cannot use this reuse frequency reuse concept. So for neighboring cells, the frequency cannot be used, but whereas some distance should be maintained. So this approach, the cell sectoring approach, it improves the capacity by reducing the number of cells in the cluster. So this increases. So when the number of cells in the cluster are reduced, so cells must be reduced. When the cells are reducing, we see that there is an increasing in the frequency. So if there is an increase in the frequency, remember that the cells should be decreased. So these goes inversely proportional to each other. Then the co-channel interference in the cellular system may be decreased. Obviously remember that the interference must be reduced. So the co-channel interference can be reduced in this cellular system by replacing a single omnidirectional antenna at the base station by several directional antennas, each radiating a specific sector. So remember that our main motto is to reduce the interference. So in order to reduce the co-channel interference, then remember that at the base station we are using some antenna. So we know the antenna definition. So what is an antenna is? Antenna is a metallic wire or rod which is meant for capturing or else radiating the electromagnetic waves. So it receives or radiates the EM waves. So at the base station, what happens is we are setting some antennas. So such antennas are the omnidirectional antennas. So we should know the definition, or else we should know the meaning of omnidirectional. So what is omnidirectional? Omnidirectional is the antennas which exhibits equally in all the sides. So at all the corners, the direction, the directivity or the gain, it will be very equal at all the points. So such antennas are nothing but the omnidirectional antennas. So we do replace the single omnidirectional antennas at the base station and several directional antennas as well at the mobile receiver we have. So what are these directional antennas? Directional antennas are nothing but if the directivity is exhibiting only in one proper direction. So such antennas are nothing but the directional antennas. So we can consider the directional antennas as horn antenna, helical antenna, Yagi-Uda antenna and patch antenna as well. So all these common antennas comes under the directional antennas, where they propagate the unidirectional or bidirectional mechanism. So within a specified sector. So this is a block diagram of cell sectoring. So first one is omnidirectional, where it exhibits equally in all the sides, and then The second one is 120 degree sector. So here you can see the cell is splitted, or else the cell has been sectored, sectored, or else it has been divided into at 120 degrees. Sectoring has been taken place here in this the B diagram, and the C diagram is alternate 120 degrees 120 degrees sector. That means what, here this 120 degrees, it is not confined only for the C, but whereas it can be changed to A and B. And the D1 is 90 degrees sector, where here the angle would be, the sectoring angle would be 90 degrees, and the sixth one is the sectoring angle would be 60 degrees. So this is how the cell has been sectored with respect to the angles. So here we know that only two cells have sectors with antenna patterns which radiates into the center cell. So we know that the cell is being sectored at different angles. So in the previous slide we have seen the cell sectored into 120 degrees, 60 degrees and 120 alternating degrees, and also 90 degrees as well. So here the two cells have sectored with antenna patterns. So we should know what is an antenna pattern. Antenna pattern is the exhibiting, or else the simple diagrammatical way of representing the beams of the antenna. So when the antenna gets into excitation, it means that it radiates some power, it radiates some energy, and that radiated energy can be seen or else can be shown with respect to the antenna patterns. So with respect to antenna patterns, I can say that the antenna patterns consist of a major beam and the minor beam. So this is called the major beam. We do represent with capital M, and these are the minor beams. Minor beams are represented with small m. So remember that the maximum directivity occurs at the major beam itself. So and we also know there is a relation between the directivity and the gain. Directivity is directly proportional to the gain as well. So when the directivity increases, it seems that the gain also increases by saying D is equals to neta into G, or else G is equals to neta into D. So here when we compare it with the situation of 6 omnidirectional antennas. So here we have 6 omnidirectional antennas. For example, you can see 1, 2, 3, 4, 5 and 6. So here we have the 6 omnidirectional antennas, and here all such six omnidirectional antennas, they do exhibit or else radiates equally in all the direction. And we know the signal to interference ratio has been increased from 17 dB to 24.2 dB, and also the signal to interference ratio improvement can be allows the wireless engineer to decrease and the cluster size with n in order to improve the frequency reuse and thus the system capacity. So just remember that in order to increase the system capacity and the frequency reuse, or else the frequency reuse, in order to improve the frequency reuse and the system capacity, remember in mind that the cell has to be sectored at different angles, and for this cell sectoring we are using few antennas such as omnidirectional antennas and the directional antennas. So this shows how 120 sectoring reduces the interference. So this is a 120 sectoring diagram where it is reducing the interferences from co-channel cells. So we know that co-channels are nothing but the neighboring cells, and out of 6 co-channel cells in the first tier, only 2 of them interfere with the center cells. So here we have 6 co-channel cells. So out of 6 co-channel cells, how many of them are interfering is only 2 are interfering. So here this cell and this cell, these 2 are getting interfered. So if omnidirectional antennas were used at each base station, then all such 6 cells would interfere with the center cell. So when you are using omnidirectional, remember that we have 6 cells which are interfere with each another. So when you are using this omnidirectional, then only any two common cells can be interferes with the center cell. And then why are we going for the sectoring? Because in order to increase the system capacity and as well as the to improve the frequency reuse. And then this approach, the cell sectoring approach, improves the S by I ratio. We know that S by I ratio is nothing but signal to interference ratio. So it was presented by Professor Lee to solve the problem to increase the load on switching and control link elements to the mobile system due to sectoring. So this Professor Lee, he has come up with this approach in order to solve the problem of increasing the load when you switch from one call to another call. So when you are switching from one cell to another call, one cell to another cell, it means that you are having, or else a burden has been taking place. So due to the sectoral. So it is based on microcell concept for cells, 7-cell reuse. So in the previous class also, when we are discussing about the cell splitting, we have the cell has been splitted into different small cells. So such small cells, for example, this is a cell and this cell has been splitted into such small cells. So you call this as microcells. So in the 7-cell reuse concept, the cell, the bigger cell has been decreased, or else it has been cut down into 7 cells, small cells. So you call that small cells as a microcells. So in this scheme, each of the zone site are connected to single base station and share the same radio equipment. So single base station has been connected to all the channels, or have been connected to all the channels, and they have been using only one single radio equipment in order to know the signal propagation. And then we have this multiple zone and single base station makeup call. So why this multiple zone but single makeup call? Because as a mobile travel within a cell, it serves as zone with the strongest signal. So here you see that this is a base station and this is a zone selector. So for some particular area, so only for some particular area, we do have a transmitter. We do in the particular region. For example, if you consider, we do have n number of channels. So for n number of channels, n number of cells have been confined to that particular area. So in each and every area, the base stations have been placed, and we know the transmitter and reception concept. So the transmitter, it transmits a signal, and the receiver will receive the signal. So in this, in between this, when the signal is transferred from the transmitter to the receiver, the signal will go through different factors, or else the signal will experience some disturbances, like as we have discussed in the previous classes. So this multiple zones, so instead of having a single zone, if you go with the multiple zones, then we can say that the making up of a call can be made very easily without any interruptions or without any delays. So here the zone concept, or else we can improve the signal to interference ratio as well. So with the help of this multiple zones, the interference can be reduced, and the signal to noise interference ratio can be improved, and also delay can be reduced, and then the delay can be reduced, and such. So these three points can be, we can see some change with respect to the interference to noise ratio, interference, and also the delay concept. So the microfiber optic link has been established from the zone sector to each channel. So each one is having a single transmitter and receiver, and this transmitter and receiver they do have the antennas. So omnidirectional antennas or directional antennas. So usually at the base station we do have omnidirectional antennas where it radiates or receives, or else it radiates equally in all the directions, right? So this is just from this concept, from the concept of sectoring. What do we understand is, first thing is, in order to improve the system capacity, or else in order to improve the cell capacity and improve the frequency reuse, the better technique that we are going forward is the cell sectoring. So likewise, the cell splitting, cell sectoring is also one of the prominent concepts. So far we have discussed about the cell splitting and cell sectoring. So sectoring means here we are divided, the cell is being divided into different sectors like 120 degrees, 60 degrees and 90 degrees alternatively as well. Whereas in the cell splitting, we are saying that the cell has been splitted into small microcells. So within the cell is getting splitted into small microcells. So what happens is, we increase in order to reduce the system capacity can be increased. So here the important points to be remembered is the system capacity. The system capacity can be increased, and also the frequency reuse can also be increased. So this is a small and a very important topic regarding the sectoring, cell sectoring, in order to have a free and without any congestion, in order to avoid the congestion, and also in order to have always establish a proper communication, or a proper communication from the user to the base station. So these are the very good prominent techniques, such as cell sectoring and as well as the cell splitting. So this is all for this day. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.